Alright, welcome back. Today we're going to talk about accuracy and precision. So accuracy refers to how close a measured value is to an accepted value. That's really important. The word accepted value is when something is accurate. Precision refers to how close a series of measurements are to one another. So accurate means you're hitting the bullseye. Okay? Accurate means you're hitting the bullseye. That's this first one right here. If I am precise, I can be precise but not be accurate. So you're precise if on every single test you take, you make a 60. That's precise. But are you being accurate? No. So precision is when you hit the same thing every single time, but you're not hitting the target. So if I am playing soccer and every single time I'm trying to shoot the ball at the goal, but I don't get it to the goal, but I hit above the goal on the crossbeam every time, I'm very precise, but I'm not very accurate. Accuracy and precision are two different things. Often we use them interchangeably, but in science we cannot. We want to be both accurate and precise, which is where we are hitting the bullseye or we are hitting the accepted value every time. And then if you're not hitting the accepted value and you're not in a hitting in a close manner every single time, then you're neither accurate nor precise. So we would rather be accurate and precise every single time. So accuracy is close to the accepted value. Precision is how close the measurements are to one another. So this slide is going to be important. For the purposes of general chemistry this year, if the error is 0.1 or less, the measurement is considered accurate. So right here, if our accepted value is 1.5, and my experimental values are 1.6, 1.4, and 1.5, all of those are within 0.1. So I would consider this dude to be accurate. And if the measurements are within 0.1 of each other, the measurements are considered to be precise. So go back and look. 1.6, 1.4, 1.5, they're all pretty close to each other. They're all within that accurate range. Even though 1.6 and 1.4 are 0.2 away from each other, since they are within 0.1 of the accepted value, I would also call this precise. Well, let's look at our next set of data. If the accepted value is 1.5, and my experimental values are 1.6, 1.7, and 1.8, this is not accurate. They are not hitting with, all of them are not hitting within 0.1 of the accepted value. But they're all hitting very close to each other. They're within that range of each other, so I would call this range set of values to be precise, but not accurate. Accuracy and precision. You would rather be both accurate and precise. So, when I'm looking at this data from earlier, from yesterday, earlier when we were talking about error. So this first person, their error is 0.05, 0.01, and 0.02. So I would say that student A is both accurate and precise. If I look at student B, their values are all over the place. You've got negative 0.19, positive 0.09, and negative 0.15. So right there, even though their average was pretty close to where our accepted value, I would not call them accurate. I would not call them precise. They are neither, because they are not all within 0.1 of each other or the value. Now this second trial right here, you could say student B was accurate on trial 2, and I would take that. So they're neither accurate nor precise, except maybe on trial 2, student B was accurate. And then if you look at student C, Student C, their error is 0.11, 0.1, and 0.12. So right there, I would say that student C, they're not accurate. They're not close to the accepted value, but they're very precise. They are hitting the they are hitting the same spot every single time. So while it's not right, they're at least in the general vicinity of each other every single time. So that is the difference in accuracy and precision.